Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today we will be discussing the last lecture of Module 4, which is Humidity and Precipitation. The topic of the lecture is Rainfall, Types and Distribution. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun. In our previous lectures, we have already covered several topics which are associated with humidity and precipitation, like formation of fogs, clouds, atmospheric stability and instability concepts also. In this last lecture of Module 4, we will be discussing the precipitation. What is precipitation? What are different forms of precipitation, different types of rainfall, and concepts and theories which are associated with rainfall and precipitation. So let's begin. The main objective of this particular video is to understand what is precipitation in general, different forms of precipitation, understanding rainfall as one of the most commonly seen form of precipitation, and theories which are associated with the formation of rainfall, types of rainfall, and zonal distribution of rainfall. We will start with simply what is precipitation. In meteorology, precipitation is any product of condensation of atmospheric water vapor that falls under gravitational pull from clouds. So precipitation is very important segment of global water cycle along with evaporation and condensation, which redistributes moisture and water on our planet. So as we know that constant water cycle is active on our planet, which is responsible for circulation, redistribution of moisture and water on our planet, with evaporation being one of the segments wherein the liquid water is evaporated in form of water vapors and it is uplifted to finally condense and form cloud after reaching a particular height in the troposphere, and the final segment being precipitation, wherein the saturated water vapor in clouds fall back to the Earth's surface, redistributing moisture and water on Earth, thus completing the entire circulation of water cycle. Therefore, precipitation is one of the important segments of water cycle also, and this precipitation which falls back on our surface is of different forms. It may be of various forms like rain, sleet, snow, hail, etc. So it can be liquid or it can be frozen, and there can be various forms of precipitation. Precipitation mainly occurs when a portion of the atmosphere becomes saturated with water vapor reaching 100% relative humidity, so that the water condenses and precipitates or fall. Therefore, the fog and mist which is found in our atmosphere does not form the part of precipitation because it remains suspended in air. The water vapor in them does not condense sufficiently to precipitate. Therefore, they are out of the category of precipitation and generally called as colloids. So one of the prominent baseline factor for precipitation to happen is the presence of particles just like dust or smoke in the atmosphere, which are very essential for precipitation. Why? Because these particles, which are also called as condensation nuclei, provide a surface for water vapor to condense upon, gather together, and become large enough to fall to the Earth's surface in snow or water droplet form. Precipitation forms in the cloud when water vapor condenses into bigger and bigger droplets of water, and when these droplets are heavy enough, they fall to the Earth's surface in various forms. If a cloud is colder and it is located at higher altitudes, the water droplets may freeze to form ice. These ice crystals then may fall onto the surface of Earth into various forms. They can fall as snow, hail, or rain depending on the temperature within the cloud and at the Earth's surface. And while falling also, when they cross various layers of the atmosphere, the temperature in those layers also affect the forms of precipitation. So the main forms of precipitation include drizzle, rain, sleet, snow, ice pellets, graupels, and hails, etc. So we will discuss one by one now what are these various forms of precipitation. Let's see different forms of precipitation along with their characteristics. So let's start with rain. It is one of the most commonly observed form of precipitation, wherein the water droplets, their size mostly ranges above 0.5 mm in diameter. Anything less than that becomes a drizzle. Then we have drizzle. Drizzle is fairly uniform precipitation which is composed exclusively of fine droplets which are very closely compacted together, and therefore they appear to float while following air currents. So they are so tiny water droplets which mainly ranges from 0.1 to 0.5 mm, and they fall with such slow settling rate that they occasionally appear to float, and they are also commonly found with fogs also, and the whole environment with continuous uniform drizzling of very minute tiny particles of rain looks like it is foggy weather. The another form of precipitation which is very common besides rain and drizzle is snow. Snow is that type of precipitation which results from sublimation, that is where the water vapor directly changes into ice. It falls as white translucent ice crystals often agglomerated into snowflakes. So these snowflakes or snow crystals are mostly branched into six pointed star shape, as you can see in the figure also, and slowly they fall under the gravitational pull because they are very light. Besides snow, we have hail. Hail is also precipitation in form of lumps of ice. Okay, so precipitation in form of lumps or small balls or globules, and sometimes they can be irregular lumps also, which are produced primarily in convective clouds like mostly cumulonimbus clouds. So these vertically towering clouds leads to condition which leads to the precipitation in form of hail. So the size of this hailstone can vary from 5 mm to even 2.5 centimeter, and they are mostly associated with thunderstorms, cumulonimbus clouds, and the hail size of 2.5 centimeters or more is indicative of very severe thunderstorms in the region. Coming to snow pellets. Snow pellets are also called as small hails. Okay, they are hails but of smaller size. Sometimes they are also called as soft hails. Snow pellets are more crisp and are of size from 2 to 5 mm. Due to their crispness upon hitting the hard ground, they often break up into frizzy snowy particles. So these snow pellets are mainly opaque grains of ice with diameter less than 5 mm. You can see in this diagram also they are mostly translucent or white color. Then we have sleet, which are also called as ice pellets. So when the raindrops fall through the layer of sub-freezing air near the Earth's surface, the raindrops get frozen to ice stage. So in this, the raindrops are frozen and they become small globules very near to the surface of Earth, and they are mostly precipitation of transparent and translucent pellets of ice, which are rounded or sometimes irregular also. So they mainly consist of either frozen raindrop or melted and refrozen snowflakes also. So they are called as sleet or grains of ice. Besides sleet, we have snow grains. Snow grains are very small, white, opaque grains of ice, mostly formed because of the frozen drizzles. Then we have ice crystals. These ice crystals are generally present in very cold regions because they are the falling crystals of ice in forms of needles or columns or even plates. So these are also called as diamond dust sometimes because ice crystals appear to look like fog with individual water particles forming directly as ice. The shape of the individual ice crystals causes the light pillar's optical effect above the light source. So it looks like optical illusions also, and it mostly looked like shining diamond particles which are scattered in the sky. So these were the main forms of precipitation which we have on our planet. So this slight animation may just give you a visual reference to what we are talking about here, that the rains are mainly water droplets, snow are flakes of frozen water droplets, then sleet we have super cooled rain droplets, and hail we finally have lumps or globules of ice which are falling from the cloud to the surface of earth. So these are all different forms of precipitation. Moving on to very important form of precipitation, which is rainfall. We have already discussed what rainfall is briefly. Now we will be understanding what rainfall actually is, how rainfall occurs, what is the mechanism behind the formation of rainfall. Since we have already talked about that rainfall is the most commonly observed form of precipitation, wherein the diameter of the droplets is 0.5 mm or more. So this is considered primarily in definition as rain. In general, rain is liquid water in the form of droplets that have condensed from atmospheric water vapor and then become heavy enough to fall under gravity. So the diameter of the rain droplets must range between 0.5 mm or more, because anything below this is defined as drizzle. So the warm air, after being heated, ascends, saturates, and condenses to form cloud. Depending upon what is the temperature of cloud, where the condensation is happening, the water droplets are formed. These water droplets are so microscopic that they remain suspended in air unless they become large enough and the air is unable to hold them. And finally, once the air becomes super saturated and water droplets become sufficiently large in size, they cannot be held in suspension and begins to fall as rain drops. Rain is major component of the water cycle as it is responsible for depositing most of the fresh water on earth, redistributing the water on earth, redistributing the moisture content on earth. So when the moist air ascends slowly, small droplets are formed. However, if the air which ascends quickly due to intense heat, bigger droplets are formed, which leads to heavy downpour. Rainfall is a global phenomenon. It is experienced in each and every part of the world. Therefore, in order to understand what is the mechanism of rainfall, several theories have been propounded in the past. To understand how a droplet is formed in the cloud, what is the mechanism of rainfall, and how this rainfall happens in different regions of the world. Although many theories have been propounded, but two theories remains most important. Those two theories are cloud instability theory and second is the collision theory. So we will discuss both these theories one by one. So first is the cloud instability theory. The theory was proposed around 1930s by T. Bergeron and it was subsequently developed by W. Finson. The particular theory provides for the mechanism for the growth of raindrop in a cloud. The theory is based on commonly accepted fact that the relative humidity of air is greater with respect to ice surface as than with respect to water surface. So it talks about the differential values for saturation of water vapor over ice and supercooled water surfaces. At the cloud temperatures of -12 to -30, air can be saturated over ice, but not over the water particles. So evaporation can take place from the water droplets and ice particles grow by sublimation, wherein the water vapor around the ice crystals have no time to condense and thus go straight for deposition into solid form or ice forms. These ice particles, just like water droplets, also require the freezing nuclei, and these ice particles gradually grow in size as the deposition of vapor derived through evaporation of supercooled water droplets on their surface continues. So once these particular ice droplets have sufficiently grown in size, they tend to collide and form snowflakes. So once these snowflakes are formed, because they are very, very large, they fall downwards under the pull of gravity, because the falling velocity of these snowflakes exceeds the velocity of rising air currents. So the ice crystals become very, very heavy, therefore fall under the gravitational pull. They fall onto the surface of Earth. And while these ice crystals and snowflakes are falling down, they pass through the warmer layers of the atmosphere, which are comparatively warmer, and these layers are super cooled layers. Okay, super cooled layers of the atmosphere. But when these particular snowflakes are falling down, they pass through comparatively warmer layers where the temperature is more than 0 degrees Celsius. And it is at this point when they change from the snowflakes or ice crystals to finally raindrops and fall onto the surface of Earth, and thus begins the rainfall. The process in cloud instability theory largely depends on the existence of or mixture of supercooled water and ice crystals together. Okay, supercooled water and ice crystals together. So it is under these conditions only the cloud instability theory will occur. The ice crystals will be formed, finally leading to the formation of snowflakes. And when these snowflakes fall onto the surface of Earth while passing various layers of the atmosphere which are comparatively warmer, they turn into raindrops. In this particular theory, the existence of supercooled water and ice crystals or ice together is very, very important. So their formation can mainly be found in the mid-latitudinal or higher latitudinal areas only. So clouds which are found in the higher latitudinal areas or mid-latitudinal areas experience this type of phenomena which is explained in this process of cloud instability theory. Therefore, this theory basically provides explanation primarily for the precipitation only in the mid-latitudinal or higher latitudinal areas. It does not provide a plausible explanation for heavy rainfall in the tropical areas, where rain can form in very low altitudes with above sub-zero temperatures, where the temperatures are more than 0 degrees, and where the formation of ice crystals does not take place. Therefore, it does not provide an explanation to precipitation around the world, and it's limited in its explanation to explain the regional or mid-latitudinal precipitation only. So in order to explain the precipitation which is happening in tropical areas, another theory was propounded which is called as the collision theory. So let's discuss the collision theory now. So coming to the second theory of rainfall formation, which is collision coalescence theory. So you have to understand this, that though the Bergeron process of the origin of precipitation and rainfall satisfied most of the observed fact, but it could not explain the mechanism of rainfall in the tropical areas, where the cumulus clouds over the oceans give copious rainfall when they are only located somewhere 2 to 5 kilometers above the Earth's surface, and they are mostly 2000-meter thick, and the air temperature is not even below 0 degrees Celsius and mostly ranges around 5 degree to 4 degree, or it can even be more even in the higher layers of these cumulus clouds. So it is thus evident that the ice crystal will definitely not form in these regions, and the growth of the raindrop of large size in these warm clouds is mainly explained by the collision coalescence theory. Therefore, the collision theory involves the collision, coalescence, and sweeping for the formation and growth of raindrops, and it was postulated by several meteorologists later on due to the dissatisfaction of the cloud instability theory. So this theory explains the water droplets big and small in a cloud collides against each other caused by convection currents in the cloud. So in this particular theory, the atmospheric turbulence causes collision of cloud droplets, and due to collision they coalesce and grow in size. So this is the basis of this particular theory, wherein you have to understand that small droplets, big droplets, they exist in the cloud, and because of certain air turbulence they tend to collide together to form bigger droplets. The initial small droplets are not dropped out but kept in suspension in the cloud until they are large enough to be dropped. So this particular collision is continuously taking place. Small droplets are being absorbed by the bigger droplets, and the size of the bigger droplets is getting bigger and bigger until the point that the cloud is not able to hold them and they fall onto the surface of Earth under the gravitational pull. So as the other large water droplets in the cloud collide with the smaller water droplets, they coalesce, they join, causing them to become more big. Okay, so at this point of time, they have become big enough and they are not able to hold in suspension for much longer in the cloud. So what happened now? Eventually, the size of these particular droplets become bigger and bigger till they are unable to remain suspended any longer in the cloud and fall as rain drops. So what happened now, because these droplets have become so big, the large drops have absorbed smaller droplets. These smaller droplets are also swept by larger droplets. So all these leads to increase in size of the large droplets, which become raindrops, which fall as rain because they cannot be held in suspension by the rising air. And once they start falling, the large droplets are ripped apart by the convectional currents and air friction, which disintegrates them into smaller droplets, leading to copious precipitation in the tropical areas. So collision coalescence theory mostly explains the rainfall phenomena in the warm convectional clouds which are located in the tropical areas of our planet. So we have cloud instability theory, which explains the mechanism of rainfall in the mid-latitudinal or higher latitudinal areas. And then we have the collision coalescence theory, which explains the formation of raindrop, which explain the mechanism of rainfall in the tropical areas. Now, coming to the types of rainfall, we know that rain is the most common form of precipitation, but for rainfall to happen, the primary condition includes that the ascending moist air must saturate and get condensed, and adiabatic cooling due to upward movement of air is by far the most important mechanism of condensation and related precipitation, including rainfall. Therefore, three primary ways in which air is forced to move upward and cools down according to adiabatic lapse rate are given here. First is heating of the earth surface and consequent heating, rising and cooling of the air, which is called as convectional mechanism also. Okay. Second one is the ascent of air parcel over an orographic barrier, which is primarily a mountain, hill, or any elevated terrain, which condenses the air parcel leading to precipitation. So this is kind of orographic mechanism. The third one is the upliftment of air, which is associated with low pressure systems, which are known as cyclonic or frontal ascent. So this is the cyclonic mechanism. So based on these three ways in which the air can be lifted and cooled down leading to precipitation, we have three primary types of rainfall. First one is the convectional rainfall, second one is the orographic rainfall, and third one is the cyclonic and frontal rainfall. So these are the three primary types of rainfall which are found around the globe. So we will discuss them one by one now. First one is the convectional rainfall. As the name suggests, it is mainly associated with the heating and cooling of the Earth's surface and consequent heating and cooling of the air parcel which is lying above it. It occurs when the energy of the sun or insolation heats up the Earth's surface and causes water to evaporate, changing it to water vapor. The air on being heated becomes light and rises up in convection currents. As it rises, it expands and loses heat, and consequently condensation takes place and cumulus clouds are formed. This process releases latent heat of condensation, which further heats the air and forces the air to go further up. The air reaches a point which is called as the condensation level, where it has cooled to such an extent that the water vapor condenses, turning back to liquid and leading to precipitation. This process of condensation high in the atmosphere leads to the development of clouds. As the clouds continue to grow, the weight of the water droplets cannot be contained, eventually leading to precipitation. So this is convectional rainfall, which primarily originate because of the convectional mechanism or heating of the Earth's surface. The second one is the orographic precipitation. When the saturated air mass comes in contact with a mountain or any barrier for that matter, it can be hill or hill complex or any elevated surface. It is forced to ascend, and as it rises, it expands adiabatically because of the fallen pressure. When the temperature falls and the moisture condenses, it leads to the precipitation. This type of precipitation occurs when warm, humid air strike an orographic barrier, as you can see in the diagram also. This warm, moisture-laden air is struck because of this mountain barrier and is forced to lift upwards. Because of the initial momentum, the air is forced to rise, and as the moisture-laden air gains height, condensation sets in and soon saturation is reached. The surplus moisture falls down as orographic precipitation along with the windward side. So as this particular parcel of air rises, it cools down, it condenses to form clouds, and precipitation takes place in form of rain. This particular face of the mountain which receives the rainfall is called as windward side, while the mountain slope which is devoid of rainfall is called as leeward side of the mountain. So while the windward side receives maximum precipitation, the leeward side receives no precipitation and particularly remains rainless and dry. The area which is situated on the leeward side, which gets the least rainfall, is also called as the rain shadow zone. Okay. So this is called as orographic precipitation. The third type of precipitation is frontal or cyclonic precipitation. So as you know that different regions of the world produces different types of air masses. These air masses can be cold, they can be warm. But because these air masses have contrasting temperature, humidity, and other characteristics, they do not converge readily. So in the zones of their convergence, a shallow boundary is formed between them, which are called as fronts. And these frontal areas, which represents the transition boundary between the two different air masses, are areas of turbulence. Along the fronts, convection occurs and causes precipitation. So we'll be dealing with fronts and air masses in detail in the coming videos, but just understand for now that frontal regions of the world represent transitional zones between the two contrasting air masses, because of which there is a turbulence, convection leading to rainfall and precipitation in these areas. So it results when the leading edge of a warm moist air mass meets a cool and dry air mass. So as they proceed to meet, what happened? The warm air mass is not able to mingle with the cold air mass properly, and it kind of is tossed up by the air mass, leading to the formation of cumulonimbus clouds, and heavy precipitation takes place in those areas. The molecules in the cold air are more tightly packed together, and thus the cold air is heavier than the warm air. So it wants to remain at the surface. The warm air mass is forced up over the cold air. As it rises, the warm air cools, the water vapor in the air condenses, clouds are formed, and precipitation takes place. And this kind of precipitation is very, very common in Atlantic areas, northern, mid, higher latitudinal areas along Canada, USA, and certain regions of Europe also. So this type of system is called as frontal precipitation or cyclonic precipitation, because these fronts are also the zones of temperate cyclones, which leads to heavy precipitation in these areas. And because the moisture tends to occur along the fronts of the air mass, the heavy precipitation takes place along the fronts, which is called as frontal precipitation. So these were the three major types of rainfall. First one was the convectional rainfall, second one was the orographic rainfall, third one is the frontal rainfall. So besides these primary three types of rainfall, we also have monsoonal rainfall. Although we have discussed monsoonal rainfall in great detail in module 3, where we have discussed the monsoon winds and its mechanism, but this is also a kind of rainfall which is experienced in the Indian subcontinent. So this type of precipitation is characterized by seasonal reversal of wind. So there is 180-degree reversal of wind systems here which carry oceanic moisture, especially the southwest monsoon with them, and causes extensive rainfall in the South and Southeast Asia. So when the southwest monsoon crosses the equator and enters into the Indian Ocean, they pick up the moisture from Indian Ocean and they causes heavy rainfall in the coastal areas of India, along both the coast of India, the western coast also and eastern coast also. And then in winters we have again 180-degree reversal of winds, and we have the retreating monsoon winds, which again pick up moisture from the Bay of Bengal region and causes rainfall in the certain states of South India. So this is the monsoonal type of rainfall where we experience 180-degree reversal of wind system. I will not be going into much detail here because we've already discussed this as part of module 3. Coming to the global rainfall distribution or global distribution of rainfall, different places on Earth's surface receive different amount of rainfall in a year, and that too in different seasons. In general, as we proceed from the equator towards the pole, the rainfall decreases steadily. Okay, the coastal areas of the world receives greater amount of rainfall than the interior of the continents, because the air picks up moisture from the oceans and then they causes heavy rainfall along the coastal areas, and once they enter into the continental interior, that moisture is lost in the air, causing less precipitation. The rainfall is more over the oceans than on the landmass of the world because of being greater source of water. Between the latitudes of 35 degrees to 40-degree north and south of the equator, the rain is heavier on the eastern coast and goes on decreasing towards the western coast, mainly because of the predominance of trade winds in these particular areas. But between the 45 and 65-degree north and south of equator, due to the westerlies, the rainfall is first received on the western margins of the continents and it goes on decreasing towards the east. So along the mid latitudes or high latitudes, we have higher precipitation along the western margins, while in the tropical areas, we have the more precipitation along the eastern coast. Whenever the mountain run parallel to the coast, the rain is greater on the windward side, it decreases towards the leeward side. So if a particular area, if any region, for example India only, you have mountain barrier along the coast, so these rain bearing winds come and strike this mountain and they are lifted because of this orographic barrier, leading to precipitation in the coastal areas. So coastal areas receive more rainfall. And once these rain bearing winds have given all their moisture, have led to precipitation along the windward side, the leeward side, these particular winds become warmer adiabatically while coming down the slope of the mountain. And once they become warmer, the pressure increases, they become warmer, and the leeward side do not receive rainfall. So this is the global pattern of rainfall. So, based on the global seasonal behavior and variations of rainfall around the world, 6 rainfall zones have been identified globally. So, let's discuss them one by one. The first one is the equatorial zone of maximum rainfall, where the rainfall is experienced throughout the year. And most of the rainfall is mainly of convectional type. Why? Because these areas receive direct high insolation as compared to other areas of the world. And this particular zone extends up to 10-degree latitude on either sides of the equator and falls within the intertropical convergence zone of trade winds, characterized by warm and moist air masses. The mean annual rainfall ranges between somewhere around 1500 mm to 2000 mm. So most of the rainfall is received through the convectional rainfall, and which is also accompanied by thunder and lightning due to the formation of huge towering cumulonimbus clouds in these areas. So the daily rainfall generally happens during the afternoon time period, and the rainfall intensity is very, very high. But it is also of short duration, and the sky after some time gets cleared and becomes cloudless in the evening hours. So the equatorial zone is of maximum rainfall, which receives very high rainfall throughout the year, which is mostly convectional. The second zone is the trade wind rainfall zone. So it is located within the tropical areas of the world, which extend between 10 to 20-degree latitude in both the hemispheres, and it is characterized by the northeast and southeast trade winds. So there are rainfall maximum and minimum time periods which are experienced in these areas. The trade winds, they yield maximum precipitation mainly in form of rain, and this particular rainfall is mostly experienced in the eastern part of the continents because of the onshore trade winds which pick up moisture while entering the continental territories. So the eastern part of the continents in this particular zone receives more rainfall, and the rainfall is concentrated primarily in the summer time periods, while the December time periods have received very, very less rainfall. So these areas receive seasonal rainfall, wherein maximum rainfall is received during the summer time period and minimum rainfall is received during the winter months. So monsoon regions within this particular trade wind zone also receives very high rainfall, and the rainfall in monsoonal areas is also concentrated during the summer months only. And these monsoonal areas are associated with 180-degree reversal of wind system, leading to high rainfall in 4 summer months of the year, which is from July to August. Besides trade wind rainfall zone, the third rainfall zone is subtropical zone, which is of minimum rain. So why it is of minimum rain? Because you know that it extends between 20 to 30 to 35-degree latitudes in both the hemisphere, which is a high pressure belt area. And because it is a high pressure belt area, there is always descent of air from above, which induces high pressure and winds diverge in opposite direction, causing anticyclonic conditions, causing high pressure conditions retarding the rainfall in these areas. So this condition is not conducive for rainfall, and therefore dry conditions prevail in most of these particular areas which lie in this latitudinal belt. And therefore you can see that most of the deserts are also found in this particular belt because of low rainfall. But most of the deserts are generally concentrated in continental interiors because the eastern part of the continents continue to receive rainfall from relatively moist trade winds which come from over the oceans. So most of the annual rainfall occurs during the months of summers, and the winters are primarily dry. The fourth one is the Mediterranean rainfall zone. So this zone extends between 30 to 40-degree latitudes in both the hemisphere, where the rainfall occurs primarily through onshore westerly winds. During the winter season, while summer remains dry because these zones come under the influence of trade wind due to the northward shift of the winds and pressure belt during the northern summers. So in winters, you have onshore westerlies, which leads to heavy precipitation in these particular areas. Whereas in summer season, you have offshore trade winds and therefore they receive very less precipitation in summer season. Thereafter, you have mid-latitudinal zones of high rainfall. Besides Mediterranean rainfall regions, the mid-latitudinal zones of high rainfall extends between 40 to 50 degree latitudes in both the hemisphere, where rainfall occurs through westerlies and primarily the temperate cyclones. The mean annual rainfall somewhere ranges between 1000 mm to 1250 mm. The western part of the continents in these areas receives more rainfall. Why? Because of the onshore westerlies in these regions. So the western part of the continents receives more rainfall, and as you move inwards towards the continental interiors, the rainfall again decreases. So the southern hemisphere in these particular zones receives more rainfall than the northern hemisphere. Why? Because of the dominance of oceans in the southern hemisphere as compared to the northern hemisphere. And winter season receives maximum precipitation again in these areas, primarily because of the prevalence of temperate cyclones during the winter season. The precipitation is primarily of uniform nature and it happens for very long duration. The last one is the sixth rainfall zone, which is the polar zone of low rainfall. The precipitation tends to decrease from 60 degrees, okay, in north and south in both the hemispheres towards the poles, and the mean annual precipitation decreases to less than 250 mm also. So beyond 75-degree latitudes in both the hemispheres, you have very less rainfall, and whatever precipitation you receive, you primarily receives in the form of snow. So you have low rainfall and precipitation is primarily received in the form of snow. So these are the six primary rainfall zones of the world, where equatorial zones have maximum rainfall and receive rainfall throughout the year. Then you have trade wind rainfall zones with seasonal rainfall, which peaks up in the summer season and is drastically reduced during the winter season. Then you have subtropical zone of minimum rain because of existing high pressure belts in the area. The area receives very less rainfall, and whatever rainfall the area receives, it is primarily received in summer season. Thereafter, you have Mediterranean rainfall zone where the rainfall is primarily in the winter season. Again, in mid-latitudinal zones, you have high rainfall because of onshore westerlies in these areas. And finally, in the polar zones, you again have low rainfall. Why? Because of the very low temperatures, and the precipitation is mainly in the form of snow. So these were the six rainfall zones of the world. Let's try to understand these particular zones with the help of global rainfall distribution map also. Now let's quickly see this global rainfall distribution map. Although we have discussed thoroughly in the last slide what are the different characteristics of rainfall zones in the world, but just let us see their latitudinal position on this particular map also and their rainfall distribution characteristics. So as you can see that the equatorial areas, which are located 5 degrees north and 5 degrees south of equator, they receive rainfall throughout the year. And the rainfall is also of torrential nature. Very heavy precipitation can be seen in these areas throughout the year. Then you have tropical areas which extends for nearly 20 degree, 10 to 20 degree north and 20 degree south in both the hemispheres. So here you can see that you have onshore trade winds which give maximum precipitation in these areas, leading to heavy rainfall. Seasonal rainfall in these areas can be seen because of onshore trade winds. So one very important feature of this particular area is the eastern part of the continents receive very high rainfall, as you can see in this particular map also, and the western parts comparatively receive less rainfall. Why? Because there you have offshore trade winds. So moving on to the subtropical zone of minimum rainfall, as you can see in these particular areas that you have very less precipitation in these areas. Why? Because these areas generally extend from 20 to 30 degree north and 30 degrees south in both the hemispheres. And you can see that these particular areas have high pressure belt. They fall under the high pressure belts, leading to anticyclonic conditions in the area. Okay, anticyclonic conditions in the area. Therefore, these areas of the world receive very less precipitation. Although some precipitation can be seen primarily in the eastern part of the continents. Okay, eastern part of the continent still receives little bit of rainfall because of the effect of trade wind in these areas. However, the continental interiors, as you can see, are devoid of precipitation. Therefore, most of the continental deserts of the world can be observed in these areas. As you can see, the Sahara Desert, then you have the Atacama Desert, then you have the Australian Desert, Iranian Desert or Arabian Desert. So these deserts can be observed in these parts of the world. Besides this, as you move towards the polar region, you again have Mediterranean zones which are located 30 to 40 degree north and south of the equator. So these areas also receive very heavy precipitation. Mediterranean type of climate is primarily found along the Mediterranean Sea border areas in the southern parts of Europe, and Mediterranean type of climate is also found in the California region of America. So these winds often receive winter precipitation, and precipitation is maximum in the winter season. Why? Because of the onshore westerlies. So onshore westerlies can be seen in these particular areas, and these areas, because of onshore westerlies, due to the apparent movement of the sun during the winter season, the westerlies become onshore, and these areas receives very high precipitation during the winter season. And during the summer season, you have offshore trade winds in these areas, and the areas are devoid of precipitation. So Mediterranean areas receive maximum rainfall during the winter season, primarily because of onshore westerlies in these regions. Then you have mid-latitudinal zones of very high rainfall. So you have westerlies in these particular belt, and therefore these areas receives very high rainfall. So western part of the continents generally receive very high rainfall in these zones because of onshore westerlies in this particular belt, which extend from 40 to 50 degree north and south of the equator in both the hemispheres. So these areas receives rainfall primarily due to onshore westerlies. Beyond 50 degree and beyond 60 degree north and south of the equator, the rainfall is very less. And whatever precipitation you receive in form of snow. So 60 degree and beyond, even 75 degree north and south of equator, in the Greenland area, in the northern parts of Canada, in the Siberian area, and in the Antarctic region, you can see very heavy precipitation in the form of snow, and rainfall is very limited in these areas. So this was all about the global rainfall distribution. So summarizing the video now, precipitation is any product of the condensation of atmospheric water vapor that falls under the gravitational pull from the clouds. So it can be liquid in form of rainfall, and it can be solid in form of snow. Different forms of precipitation exist, which can be drizzle, rain, sleet, snow, ice, pellets, graupels, and hail, etc. And rainfall among them is one of the most commonly observed forms of precipitation, which is in liquid form. It is in form of droplets that have condensed from atmospheric water vapor, and they fall under the gravitational pull of Earth in form of water droplets. Different theories of rainfall development have been propounded from time to time, but two theories, that is the cloud instability theory and collision coalescence theory, are one of the most prominent theories which helps in understanding the mechanism of rainfall development. While the cloud instability theory mainly talks about the formation of ice particles, super cool water droplets inside the cloud. And while these particular ice particles fall from the higher limits of the atmosphere, they are converted into droplets. And cloud instability theory mainly talks about the rainfall mechanism in the mid-latitudinal and higher latitudinal areas, while the collision coalescence theory talks about the rainfall formation or rainfall development in the tropical areas, where various big, small, tiny droplets collide together to form very big water droplets, and small and big water droplets all exist inside the cloud and falls finally when the cloud is not able to hold them, leading to the heavy copious precipitation and rainfall in tropical areas. Then you have different types of rainfall depending upon how the air is lifted. What is the mechanism of lifting of the air in the atmosphere? It can be convectional rainfall, it can be orographic rainfall, and frontal rainfall. Besides this, we also have monsoonal rainfall, which is experienced in Indian subcontinent. So rainfall distribution basically varies very much spatially and temporally also. It can be experienced throughout the year in some parts of the world, while it can be seasonally experienced in other parts of the world. In some parts of the world, the precipitation can be in form of snow, which can be experienced in certain months of the year, while in other months of the year, the precipitation can be in form of rainfall. So precipitation or rainfall distribution varies globally very much. It can spatially vary depending whether the rainfall is happening over the continental areas or it is happening over the oceanic areas, it is happening over the coastal areas or mountainous areas. So there is a spatial variation in the distribution of rainfall. Along with spatial variation, you also have the temporal variation, because certain parts of the world experience rainfall throughout the year, while certain parts of the world experience rainfall just in the summer season. Other parts of the world experience rainfall in the winter season, and some parts of the world does not even experience the rainfall throughout the year entirely. So this is all about the rainfall, its theories, its formation, its distribution around the world. So I hope the video was informative. Thank you.